All right, fourth graders. Before we begin classifying triangles, we are going to review types of angles. So let's start with acute angles. So an acute angle is any angle that has a measure that's between 0 and 89. And one way I like to think about it is when you look at it, is it smaller than the corner of your screen? So if you were to make a right angle, I'm going to do it in the corner of mine. That's a right angle, the corner of my screen. Ooh, that's not really working. But anyways, that's a right angle in the corner. Is the angle smaller than the corner of my screen? Then yes, it's acute. The same thing, if the right angle, if it looks exactly like the corner of my screen, or we've got that little box, or it says it's 90 degrees, then we know it's a right angle. Right angles are exactly, can only be one thing. It can only be 90 degrees. Acute can be many, obtuse can be many. And then you look at, for the same thing, just keep using that frame of reference of the corner. Is the angle bigger than the corner of my screen or is it not? And if it is bigger, it's obtuse. If it's smaller than the corner of your screen, it's acute. Just so you have something to think about. All right, first thing we're going to do is we're going to review classifying triangles by their angles. And I'm going to highlight as I read so you know exactly where I am. So the first is an acute triangle. So an acute triangle, we've just learned about that word, is a triangle with three acute angles. So what that means is all three, oops, I don't want to use that. All three of the corners, or the corners, have angles that are smaller than the corner of our screen. If this triangle, for example, had numbers, it'd be like 60 degrees, 60 degrees, 60 degrees. All of those corners of our triangle are less than 90, less than 90 degrees. So we know it's acute. All right. Now, an obtuse triangle is a little different. An obtuse triangle is a triangle with one obtuse angle. We know obtuse means it's bigger than the corner of our screen. Obtuse is wider than the corner of our screen. So right here, I already see an angle that would be wider than the corner of my screen. And then it's got two acute angles. But one is bigger, so then it is an obtuse triangle. Okay, a right triangle. Ooh, did not mean to cross it out. I don't want you guys thinking that we don't need the information. A right triangle is a triangle with one right angle. So just like an obtuse angle, it has one right angle. And right here, I'm seeing something right here. It doesn't show me that it's got the box and doesn't say 90. And all of yours will say 90 or have the box, but it looks exactly like the corner of my screen. I'm going to try to draw it in again. Just like the corner of my screen. Ah! It won't let me do it because I'm getting too close. Just like the corner of my screen, so I know it's a right angle. What kind of triangle is this? Since we're classifying by angles, I'm just gonna circle all the three angle measures. Okay. First thing, are all three acute? Are all three less than 90? Less than 90 degrees. Right away, I see that 96 is bigger than 90. Okay, so it can't be acute. Right. Is there an angle that is exactly 90 degrees? I see 96, it's close, 49 and 35. None of them are exactly 90, so it's not right. Obtuse, is one of the angles bigger than 90 degrees? Yes. 96 is bigger than 90, so obtuse would be the answer. Let's do another one. So a triangle has angle measures of 34, 91, and 55. What kind of triangle is it? So we're going to draw a picture, and we're going to have 34, 55, and 91. Okay. Now, this one is kind of confusing because if we look at this corner right here, it does kind of look like the corner of our screen, right? However, we know that a right angle, I'm going to do this is the sign for it. A right angle must be 90 degrees. It has to be exactly 90. And is 91 90? No. So we're going to cross it out. Okay, let's go back to acute. Are all three of the angle measures smaller than 90? The answer should be no, because 91, that's bigger than 90. So it's not acute either. So we have another obtuse triangle. Okay, so a triangle has angle measurements of 90, 52, and 38. So just like the last problem, I'm going to draw a picture. We've got 90, 52, and 38. And I bet some of you already can tell which type of triangle this is going to be, but let's go through the process. So is it acute? Are all three angle measures less than 90? Well, 52 is less than 90, 38 is less than 90, but is 90 less than 90? No, so it can't be acute. Next is right. Are one of the angles equal to 90 degrees? Well, right here, we just circled it. That one is equal to 90. So since it has one right angle, it is a right triangle. We don't have to go any further. All right, so now we're going to be classifying triangles by their edges. So if we recall, the edges are the outside, kind of like what we would draw when we're drawing a triangle. So in an equilateral triangle, if you remember, we see the word equal, and equal kind of sounds like equal, and that's because they mean the same thing. So equilateral means all sides have the same length. So these little lines are like little codes that tell us that all three of the sides are equal. In an isosceles triangle, two sides. So we only have two that are the same. So it would be like 10, 10, and 9. And then a scalene triangle, all three of the sides are the same. So different, not the same. So this could be 9, this could be 11, and this could be 8. They all have different sides. So for these next couple of problems, we're going to just be focusing on the side lengths. Okay, is this triangle equilateral? Well, let's see. Equilateral means they all have the same side length. Does this side look like it's equal to this side and this side? I know we don't have side lengths, but does it look like they have the same lengths? I would say no, it does not. It is not equilateral. And just to review, what kind of triangle would this be if we were classifying by angles? Would it be acute, obtuse, or right? We're going to look at the three angle measures. Would it be 37, 48 are acute, but we've got this one that's bigger than 90, so it would be an obtuse triangle as well. Obtuse. But this is not equilateral because the sides are not equal to each other. All right, is this triangle scalene? Let's look at the definition of scalene. All three sides have different lengths. Well, one thing is we've got two angle measures that are the same. So that means that these two angle measures, when we have an isosceles triangle, we also have two of the same angle measures as well, which is kind of confusing because we haven't really talked about that. But since these have two of the same angle measures, that means that these two sides are equivalent or equal. So this actually would not be scalene because this side and this side have the same measure because they have two equal angle measures. So this would be no, it's isosceles. Because if we also look at these little symbols right here mean two equal angle measures. So we have two equal angle measures in the corner, so then we know that is also true. So it's not scalene. All right, so a triangle has side lengths of 11, 13, and 12. Is the triangle isosceles? So we'll draw our triangle. We've got 11, 13, and 12. Do we have at least two sides that have the same length? 11, 12, 13. I see none that are the same, so it is not isosceles. All right, good luck on your work classifying triangles. Remember to look at each of them critically, draw pictures, and think out loud.